Hey everyone. So lately I've been spending some time playing around with this specific look you see on the screen. I'm really happy with how it turned out. We're going to focus on how to get all the movement and the sizing to feel just right. So that said, let's jump straight into TouchDesigner and get started. Hey everyone. Based on the animation you just saw, we're going to learn how to easily recreate this effect inside TouchDesigner. I've built this network in a very structured way, focusing specifically on how we can manipulate chops to drive the look. Creating this is actually quite simple. First, I'm going to clear out these operators. I'll keep only a few specific ones, like the camera and lighting, because they use customized values I don't want to lose. Everything else is going away. Okay, let's start by adding a constant chop. In the name parameter, we'll create a channel called numPoints and set its value to 8. Next, let's bring in a line SOP. We'll take that value of 8 from our constant chop and reference it directly in the number of points parameter of the line. Now, we'll attach a null to the line SOP and use a SOP to chop to convert that data. Then, we'll add a pattern chop and switch its type to ramp. To ensure our number of instances stays consistent, we'll reference the constant's value in the length parameter here as well. For the phase parameter of this pattern chop, we'll apply a Python expression. You can just copy the one appearing on the screen now. After that, we'll go to the Channel tab and name it Scale. Next, we'll use a math cop to remap the values. They currently range from 0 to 1, but we want to scale them from 0.1 up to 6. We also need a noise chop. In its settings, let's drop the period to 0.05 and the amplitude down to 0.24. Over in the translate z parameter, we'll use the abstime.seconds expression so the noise stays animated over time. We'll also define 3 channels for rotation: Rx, Ry, and Rz. Right now, the rotation is way too subtle, so we'll need another math chop to boost those values. Before we do that, set the noise's start and end parameters to samples, and reference our constant chop in the end field. Subtract 1 so the total sample count stays at 8. Now, as I mentioned, we need to rescale those rotation values. They're currently sitting between -0.5 and 0.5. So let's remap them to a full range of -360 to 360. From there, we'll take the SOP to chop and add a merge chop and combine all these channels together. Finally, attach a null chop. With that done, we'll quickly tidy up the existing render network. Now bring in a box SOP. Let's set the size of this box to 2. We'll also add a sphere SOP and change its type to polygon. Reduce the frequency in the details to 1. Next, add a transform SOP and slightly increase its uniform scale. Then, use a boolean SOP to perform a boolean operation. We're going to use the second sphere to cut into this box. In the boolean operator settings, set the operation to AB. Now, use an attribute create node to compute the normals and tangents. Follow that with a null. Next, we'll use a geometry comp. The camera and light are already set up, but feel free to adjust them to your preference. Now, let's add a secondary geometry comp and arrange it over here. For the materials, we'll use a PBR material. We need to import something first. Import a substance top and load the strawberry theme. Drag that into the PBR material as a substance top. Then apply it to geometry comp. You can use any substance you like. Next, take a line material and drag it onto the second geometry comp. In the line material settings, set the line near and far color to pure white, so the lines stay fully visible. Now, add an environment light and drag our existing movie file into it. Then, increase the environment light intensity to 2. These are the specific values I've set for the camera and lights. You can copy these exactly or customize them to fit your own style. Now I'll import a render top to generate the final visual. It's not quite visible yet, but there's no need to move the camera. I'll turn on instancing now. We'll drag in the instancing data I prepared earlier and set the values one by one. You can follow along with what's on the screen. Okay, we'll repeat the same process for the second geometry. Drag in the null chop and map the values to the translate, rotation, and scale parameters exactly as we did for geometry 1. Okay, you can see the animation is starting to take shape. It looks good, but the background is still transparent, which is the missing piece. To fix the background, connect a null top after the render. Add an RGB key to create a solid black background. Then import a level top for some minor color adjustments. In the level top, set the invert parameter to 1. I find this inverted look works much better than the original dark version. Next, connect an HSV adjust top to make the colors pop even more. Feel free to experiment with this. I'm setting my saturation to 4. Now I'll add an LFO chop and drop the frequency to 0.05. Then, I'll use a math chop to rearrange those values. I'm doing this so the colors of the visual shift over time. To make that happen, I'll reference this value in the hue offset of the HSV adjust top. Finally, add a null at the end of the network, and the visual is ready. It's lagging slightly because of the real-time render on my laptop. I hope this tutorial made it easy for you to create this visual. I'll see you in the next video. Goodbye for now.